All right, now we're going to go to rules of implication 2, and I'm going to give you 4 more rules of inference. Okay, remember there's 18 rules of inference. They call the first 8 rules of implication 1, rules of implication 2. They call the last 8, 16 total, but the last 8 rules of replacement 1 and rules of replacement 2, but all of them are called rules of inference. And the next set of videos for section 7.3, I'll tell you how to use the rules of replacement. Kind of similar, but there's some differences as well. Okay, so here are the 4 additional rules of inference for rules of implication 2. Okay, so you already had 4. The 5th one is constructive dilemma. Here's the form, and when I do examples, you'll understand how that all works, okay? And you've had constructive dilemma, this argument form, in section 6.6, okay? Here are 3 more that are new, but this is something that'll make you feel better. Some of you are going, okay, I'm just trying to figure out how to use the 4, and now you're bringing in another 4, so now I've got 8. Oh my gosh. Well, to help you not panic, this should put your mind at ease. Simplification is basically if you have a conjunction. Now you got to remember, simplification only works with the dot operator. You can't use it with anything else. But what it's really saying is, if you have a conjunction, you are allowed to bring down one of the conjuncts. P is a conjunct, Q is a conjunct. They have been conjoined. Okay, here, let me do this. Okay, I've got 2 water bottles here, everybody. Can you see that? They're conjoined, right? I've put them together. And you remember, for a conjunction to be true on the truth tables, both conjuncts have to be true. So if you're conjoining them, it means that this water bottle exists and this one does, right? So with simplification, if they both exist, you're able to pull it apart and bring one down. Okay? So that's the concept here. So if you have a conjunction, you can bring down one of the conjuncts. So if you have both P and Q, through simplification, you can bring the P down. Conjunction is kind of the difference. Now conjunction also, everybody realize, only works with the dot operator. One way to help you figure out what to use and what not to use is please do pay attention to the operators. So if you have P on a line all by itself, you're affirming. If you have Q on a line, so you have a water bottle on one line and you have another water bottle on another line, you can conjoin them. You can bring them together. Because both are affirmed, you can bring them together. Okay? So that's what conjunction is. And you got to remember, P and Q could be anything. It could be a conditional. It could be a big, long compound proposition. Whatever P is and whatever Q is, you can conjoin them. And then addition, this is one of my favorite rules just because it comes in handy. But some of you might be going, huh? How could you be allowed to do that? Well, you can. Now, addition only works with the wedge operator. You can't do addition with the conjunction. And what addition is if you have any proposition, which could be anything represented by P, you can add something to it with the disjunction. And here's the reasoning. You remember with a disjunction, you could have true, 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 false, false, true, and then false, false, right? And a conjunction is true if you have at least one of the disjuncts true. It's only false if you have both of the disjuncts false, right? So if you're affirming P, whatever it is, you're affirming it, then you can add anything to it, even if whatever Q is false. Because look, Q is, if you have a false, one of the disjuncts is false in a disjunction, it still can be true. And since you're affirming P, if you add something, anything, and it's false, it's still a true disjunction. So that's the thinking behind that. Okay, now with that, let's start doing some examples. Now I have some strategies up here. I won't go through the strategies right now. I'll do it after I've done with these examples because you'll understand them, just like with section 7.1. So we'll start doing some of these examples, but here's the thing I want you to remember. Constructive dilemma, okay, you've got some things to think about there, right? But simplification, conjunction, and disjunction, no, simplification, conjunction, and addition, those are fairly straightforward. So even though I've given you 8, really when you look at those 3, I have 3 that are simple. I haven't really piled on a lot more. So this is just a way for you mentally to kind of get used to that. Okay, so we're going to see how this all works. Okay, now remember, every time you do natural deduction, you look at what we're supposed to derive. We are supposed to derive this D, right? So you look for the D first in the premises, and there is the D right there. And we know if we get this whole thing by itself, if we can get both D and E isolated, can't you see how we can bring the D down through simplification? So the trick with a lot of these proofs is look where what you want to derive is in the premises and figure out a way to get it all by itself, to isolate it. So if I want to get that D, I'm going to have to get this, both D and E, isolated by reproducing this antecedent, okay? And then I can use modus ponens. So I know I need to get that B, and there is no C anywhere else. I'm going to have to add it, okay? But if I can get both D and E isolated right here, I can get the D. So just follow me, and this is one of those things, like I said, the light bulb has to turn on. So look at 1 and 3. If we had these all by itself and you were ignoring 2, if we had over here, if A, then B, that's line premise 1, and premise 3 is A, all of you would have no problem seeing that this is B, okay? So I'm going to use 1 and 3, and I'm going to get B by modus ponens, right? And remember, this is all working backwards. And then what I'm going to do is I'm going to add a C. So this will be 4, and this is just one line you used. And then you're going to say addition, okay? And all of this is for a reason. Now that I have B and C, I can get D and E through modus ponens, and that would be line 2 and line 5 modus ponens. And just for review, let's make sure you understand this. Remember, here's the P, there is the Q, here was the P again, and there's the Q, right? If P, then Q, P, therefore Q, that's modus ponens. And then, since I have that, I will bring D down because I'm pulling apart a conjunction, because a conjunction is only true if both things are true. So D's affirmed, bring D down, and I would say 6 simplification, okay? And remember, with simplification, a new twist here, we just needed one line. And with addition, we just needed the one line. All the other ones up to this point, like modus ponens, we needed 2 lines, okay? All right, there's our first example. Let's do a couple more on this video, and then I'll give you 4 more examples, or 2 more on the next video. All right, here we have 4 premises, and we're trying to derive either L or T. Now, you want to look at this. If this is our conclusion, either you're going to get it through addition, but I see a T here, so it doesn't look like we're going to need to use addition because there's a T there, or because of our new rule of inference, let's go back up here. Here's constructive dilemma. The conclusion here is a disjunction. So, if the conclusion, what you're trying to derive is a disjunction, consider using addition, which I don't think we'll need to use, or constructive dilemma. And I'm smelling constructive dilemma is going to work here. And remember, everything you're looking at, there is a way to derive these things. So you're looking for clues, or you're looking for, we could call them breadcrumbs. There are breadcrumbs here to get you on the right track. And here's why I think we need to use constructive dilemma. Is if we're trying to derive a disjunction, constructive dilemma involves another disjunction. There it is. And I see a lot of conditionals here. And if you were going to go back to constructive dilemma one more time, you see it involves two conditionals that are conjoined. The second premise is a disjunction. What you're concluding is a disjunction. Well, these premises offered here have everything we need. And it's good to kind of sketch this out. If your conclusion is if L or T, and constructive dilemma is going to work, and our second premise is going to be that either K or M, and we have these two, we're going to need two conditionals conjoined. Well, I see if we have an if K then L, let's say we had if K and L here, if K then L, and you remember constructive dilemma from section 6.6 is it's two modus ponens put together. So if K then L, K then L, that works. Now what about this one? If we had if M then T, if we had if M then T, M therefore T, that's not going to work. So that conditional's not going to work, but there's something else we can do. There's another conditional right here, and let's say we had this by itself. What we need in here, and you're thinking backwards, what do we need? We need if M then T, okay? If we had a if M then T, M therefore T, right? Is there any way to get an if M then T? And I can see if we can get this if M then N by itself, and over here on the side, everybody, everything we're doing here, this is all scratch work. Until you get real good at this, a lot of times you can imagine it in your head. Do scratch work. I do scratch work still on stuff that requires a lot of steps. You're experimenting. If we get this by itself, because we know this won't work, if M then N, M, therefore, if M then M. Okay, wait a minute. We're doing the hypothetical. If M then N, and if N, okay, there we go. Let me erase that. All right. Let's go back here. We're doing hypothetical syllogism right now. So if I get this down through simplification, I use it with this. Maybe with hypothetical syllogism, we can get this, right? And I think we can. If M then N, if M then T, we get if M then T. So we figured this out. Let's get this by itself, use hypothetical syllogism with this, and we can get that. Okay, and we know constructive dilemma is going to work. Okay, so let's bring this down. If M then N, and that's going to be 2 simplification. And you can do that because this is a conjunction. There's the dot. Then everything we do is a reason. We're going to use this with this to get if M then T. And that means we used line 3 and 5 HS, right? Lines 3 and 5 HS. And then now with this, let's conjoin it with right here. We have our two conditionals. If K then L, both if K then L, and if M then T, and that would be 1, 6 conjunction, not hypothetical syllogism. Okay, we conjoin these. Conjunction. And now we can get our conclusion. It's because we use line 7 and line 4. Those two will give us either L or T. And so we're going to put 4, 7, constructive dilemma. Okay, and what really started this whole thing is when I knew we had to derive a disjunction and knew we didn't need to use addition because the t was there. There were a lot of breadcrumbs. I think we can use constructive dilemma. I'm seeing conditionals. We may have to use hypothetical syllogism to get this one here. And I saw that we could do that. Everything worked out. Okay, so 2 simplification, 3,5 HS, 1,6 conjunction, 4,7 constructive dilemma. Okay, let's go ahead and do one more example. Okay, S or T is what we're trying to derive. Now, since this is a disjunction, we're either going to use addition or constructive dilemma. I'm thinking addition, everybody. Do you see a T anywhere here? I don't see a T at all, okay? And I only see one conditional, not two, and I don't see any disjunctions here. So we're probably going to have to add the T. And if I can get, I see the S, if I can get the S isolated, right? If we get S all on a line, we can just do either S or T through addition, right? So it seems pretty straightforward. So to get S all by itself, we need to get both not P and Q on a separate line, and then we could isolate the S. So I see the Q here, so let's simplify that, Q, and that would be 3 simplification. Okay. Now we have Q on a line. If we can just get not P on a line, we can just conjoin those and we're home free. So how could we get a not P? Well, there's a P, and I see if I can get this not M on a line, I can use not M with if P then M with modus tollens. So let's bring down the not M from 1. That would be 1 simplification. And all of this is for a purpose. I brought the not M down. It's not the case that M, because I'm going to use it with 2. So 2 and 6 is going to give us not P. So 2, 6, modus tollens. Okay, and let's just make sure you see it. Here's the P, there's the Q, here's the not Q, and there's the not P, right? So it's all there. That's all we did. Okay, I'm going to erase those. All right, get back to our ink. All right, so let's go to the next step. Now we've got Q and not P. We will conjoin those. See, they're right here. We need that to get the S by itself. So I'm going to go not P and Q, and I used line 5 and line 7 conjunction, and then 9 I'm going to use this with line 4 to get S. So we'll go 4, 8, modus ponens, and then we're home free. I'm going to add the T, and that would be 9 addition. Okay? All right, I'll do a few more examples, but as you can see, even though we have 8 rules now, 3 of them are fairly straightforward, and as you slowly move through these and add rules, this is very doable. Now again, remember, if some of you, the light bulb hasn't turned on and you're having a hard time seeing the breadcrumbs and seeing how the argument forms work, stay in section 7.1 as long as you can. You can't get too far behind because you're only dealing with 4. So in part 2, I'll just do some more examples.